Okay, as promised, I have not moved, and here we are in Chapter 1, Section 2, Intermediate Algebra. In this section, we're going to be looking at applications of linear equations in one variable. What does that mean? It's code for word problems. So I'm going to work through the solution process and talk about maybe some strategies for solving word problems using linear equations in one variable. And linear equations means that the variable that we're working with is going to have an exponent of 1, which is nice. We like that. So this first problem says that the sum of two numbers is 20. I don't know what those two numbers are. So I'm going to write down maybe a lowercase a. I'm going to enable my pen. There we go. We'll write down that the sum of two numbers, come on now, a and b is 20. Let's label them small and large. You could even maybe make this one a capital B and have the other one still be a lowercase a, so that they're literally small and large visually. The next sentence says that the larger number, b, so this is a comma, b, the larger number, is, I'm directly translating this from English into math, right? That's why I'm sort of exaggerating these words. 6 more than. So here you have to be careful. With more than, you're actually less likely to get messed up. But with if this had said the larger number is 6 less than, then you can run into trouble. So I'm going to use the same format for both. And I'm going to put 6 more than, so I'm going to add 6 to something, but I'm going to put the something before it. And that's the smaller number, lowercase a. All right, find the two numbers. I thought we were working with a linear equation in one variable. Here I've got two variables. In order to take this problem and turn it into an equation that only has one variable, I'm going to do something called substitution. I'm going to take this b value right here, and I'm going to replace it with something of equal value. I happen to know that capital B is equal to a plus 6. So I'm going to take the a plus 6 and I'm going to swap it in there in place of that b. When we do that, we end up with the statement that says lowercase a plus, not capital B anymore, but we're adding a plus 6. You could put this a plus 6 in parentheses if you felt so compelled. In this case, you don't have to. Those parentheses aren't going to do anything for us, but usually when I do substitution like this, I put my new stuff, in this case the a plus 6, I put them in parentheses. But here we don't need them. Oops, that means I have to delete that. Alright, still keep the right hand side of the equation, so equals 20. I'm going to move my way over to the right here. I'm going to combine like terms as I go. The two a's add together to make 2a. The plus 6 is still there. It's still equal to whatever that was, 20. We'll move to the right even further and then subtract 6 from both sides so that 2a is equal to 14. And then we'll go even further, dividing both sides by 2 as we go to get a lowercase a is equal to 7. That's one of our solutions. That's the smaller of our two values. And we know that the sum of our two numbers is equal to 20. We know that a plus capital B is equal to 20. Now I know that a is equal to 7, so I can literally replace the a with a 7. Added to b is equal to 20. We'll subtract 7 from both sides in order to find out that capital B is equal to 13. Both of those look like 13s, but this one was supposed to be a capital B. There we go. Just keep scribbling right over the top of it, right? Until it looks like, I don't know what that looks like anymore. Do you remember your grade school teacher told you that if you make a mistake, you should erase it and then rewrite it? Don't just scribble hard over the top of it. That's why you don't do that, because eventually it becomes unrecognizable. I'm going to do it again. I'm just going to do it better. There we go. Now it's b equals 13. All right, so those are your two solutions for that first problem. The next problem says that 5 times the sum of two consecutive integers is 705. Yikes, I don't like the sound of that. I'm going to erase this just to make some room for myself to work. Hopefully you jotted that down already, otherwise rewind and pause and write that down. 5 times, right, I'm just translating again, 5, you can put a little multiplication dot, times the sum of two consecutive integers. Consecutive means one right after the other. So maybe my first value is a, and let's say a turns out to be, let's say it turns out to be 7, since that is what it was in the previous problem. What would be the next consecutive integer after 7? Well, that would be an 8. How did you change a 7 into an 8? You added 1. So if generically a represents the first of our two consecutive numbers, the second of our consecutive numbers will be a plus 1. Now, Matt, how did you know to write that as a plus 1 and not write it as b? Well, I cheated because I've done this type of problem a lot of times. And what you're doing is you're doing some review right now, and hopefully you're going to see this style of problem enough times in your preparation, maybe for your first chapter test, that you'll know to set this problem up like this, and you'll know to set this previous problem up using two variables and then up using substitution. As it turned out in the previous problem, our second number was 6 larger than our first number. In our current problem, our second number is only 1 larger than our first number. So you're starting to see the relationship between these two types of problems. Too much. Let's get the eraser. Here we go. Is, our sentence continues to say, 705. Y'all, you can do this. Combine like terms. Isolate the variable. Let's go for it. Combine like terms, CLT. I'm going to add those a's together inside the parentheses. The 5 is still on the outside. That's 2 times a plus the 1 that's in there, still equal to 705. I'm going to, interesting at this point, you could distribute multiplication by 5 on the left-hand side, or you could divide both sides of your equation by 5. That would cancel out this 5, and you would have to divide this number by 5. Either one of those will work. I'm going to distribute. I get 10a plus 5 equals the 705. I decided that I wanted to distribute because I knew that 5 times 1 was going to give me a 5, and I'd be able to subtract the 5 away from the 705, which would make it a nice round number, so to speak. And now I'm going to do that. Let's subtract 5 from both sides. We're left with 10a equals 700. If you want to put a little note that we subtracted 5 from both sides, and then we'll keep going, dividing both sides by 10 to get a final answer of a equals 70. Oh, and Google thinks I'm talking to it. I don't know why a equals 70. Sounded like a Google command. Anyway, there's your final answer. Another conditional statement, right? The truth of this equation is conditioned upon a equaling 70. I'm going to kick the cat out. Hi, Sophie. I'm giving you Sophie.
Okay. Oh my God, I don't do that.
Me neither. The next problem, an applied problem involving interest rates and principal, and we're given this equation for simple interest, where just the interest, capital I, is equal to the principal. That's your starting balance, maybe in a bank account. And then we multiply that by the interest rate, R, and that interest rate's going to be a decimal. So if it's 5% interest, we would use an R value of 0.05. And then time is measured in years. But interesting, on the right-hand side of this equation, you're not seeing a T value. And I don't love that the author didn't put that in there, So if you want to, if you've printed these, do you have these notes? Well, if you're taking notes and you're writing down this equation, put a t in there, I equals PRT. And don't confuse this with the PERT formula, that's something else. There's actually an E in the PERT formula. And so let's see if this applies to problem number 6. A shirt in a store was originally priced at $90. It's on sale now for $67.50. Find the percent decrease. I don't think I'm going to use this equation, this simple interest equation. Instead, what I'm wanting to do is to sort of make you aware of something. If the original price was $90, and we're going to modify that 90, we're going to modify it so that the final price, it's a little difficult to articulate, is $67.50. How am I going to modify the 90? Well, I'm going to multiply it by something. I'm going to multiply it by some percent decrease. So let's multiply it by, I don't want to use capital P, let's use D for a decrease. And in fact, I'm going to rewrite this as D times 90 equals 67.50. And the reason I've rewritten it like this, it's an equal sign now, is because I'm going to write out a direct translation of this equation in English. And the translation is this. The percent that we're working with here is D, by the way, so if you want to build that into your notes. What this equation says is D percent of, and multiplication usually translates to the word of and vice versa, D percent of $90 is, and that's the equal sign, $67.50. So whatever we find as a D value is not the percent that we took away from the original price, but rather it's the amount left. It's the $67.50. So let's solve this equation now. I'm going to take this equation and divide both sides by 90. And 67.50 divided by 90. I don't trust myself. I'm using a calculator. I'm doing it. $67.5 divided by 90 equals 75%, or 0.75. So D equals 0.75, which is the same thing as saying 75%. Now here's a great example of where you want to make sure that your answer makes sense, especially in a word problem. A shirt was originally priced at $90 and now its price is $67.50. Does that sound like we decreased or discounted the price by 75% off? Does that sound like a 75% off sale to you? I don't think so. 75% is more than half. $67.50 is not more than half off of a $90 original item. So again, this D value is the percent of 90 remaining that ends up being $67.50. So maybe that circle wasn't so good. It's this is 75%. So the decrease was 25%. So decrease of 25%. If you're typing in an answer like this into an online homework problem, you will probably not need to type the percent symbol. Maybe, maybe not. I like these problems even more. After a 30% rebate, a flat panel TV is now on sale for $602. What was the original price of the TV? So we have the original price, I'm going to call that P, and we did something to it. We multiplied it by a percent, and oh, it's a 30% rebate. So that means we're only paying, after a 30% rebate, we've taken the original price of the TV. Let's even write this out. There's the original price. There's the final price. Which one of those two do you think is bigger? My guess is that the original price is bigger. And the final price is $602. So what have we done to the original price? We've decreased it. By how much? By what percentage? It's a 30% rebate, which means we're only actually paying 70% of the original price. So instead of writing a 30% here, I'm going to multiply by 0.70. You need to put in your notes somewhere that says that a 30% rebate means that we are only paying 70%, watch me now, 70% of the original price. From right to left, 70% of the original price. That's a dollar sign. You don't want to write it this way, because otherwise it looks like original of 70%. You want to flip that whole thing. So for those of you who struggle with this kind of a percentage topic, and you're like, wow, he knows to use the 70% instead of the 30%, it makes sense to me, but I wouldn't have thought to do it that way. I want to make sure I take my notes in a way that when I review this later, it's going to make sense. You should rewrite this thing that I've circled here. It should say 70% of original. So rewrite this thing from right to left instead of left to right, or however you want to say it. Now we've got the original price, capital P. Well, if we flip it, if we write it in the other order, we'll write it as 0.70 times the original price is equal to the final price. Of course, we know that the final price is $602. And now we can divide both sides by 0.70. Calculator, not doing that. 602 divided by 0.7 equals 860. So the original price of the TV before the rebate was $860. That took a long time to do that problem, and we didn't even write all that much stuff down. What I'm trying to get through to you is the strategy and a little bit of the concept. Just wrapping your mind, some of you, around the 30% to the 70%, and why are we doing it that way, and how do I know that to do it that way based on the way that the original question is phrased. That's going to be a challenge for you. So we're taking these slow, and this one we're going to take maybe even slower, and it's a good thing there's a bunch of space underneath this one because we've got some stuff to work out. This is a dual investment problem. A total of $12,000 is going to be invested in two different types of bonds. One pays this interest rate, the other pays that interest rate. And last year, the interest earned on the two bonds combined, so one interest plus the other interest as measured in dollars, is going to add together to equal $1,335. How much was invested at each interest rate? This I should make into its own video, really, because nobody likes these problems. If this were printed on a paper test, I would probably come in and circle this $12,000 invested, and I'm going to write down a note that says I'm going to invest X dollars at 10.5% rate of return. That's nice. It's also unheard of right now. Let's say, just hypothetically, that X was $2,000. I invested $2,000 at 10.5%. How much money do I have left to invest at the other interest rate. I'm investing $12,000 total. Hypothetically, I'm investing $2,000. How much money is left over? $12,000 minus $2,000, $10,000. Okay, so that's right. It means I'm investing $10,000 at the other interest rate. How did I get that? I started with $12,000. I already spent $2,000. How do you take $12,000, turn it into $2,000? Subtraction. I took this X dollar value amount and I subtracted it from 12,000. That's how much I know I'm investing at my other interest rate. That's how to figure out the amount that I'm investing at the other interest rate. Started with $12,000. Already spent X of those dollars on my first investment, so I got to take away those X dollars. That's the amount remaining that I'm going to invest at 12%. In order to find the amount of interest that I earn on my X dollars, I will take my investment and I'm going to multiply it by my interest rate. I'm going to write that as 0.105 times X, and the amount of interest that I'm going to earn on my second investment is my interest rate, which is 0.12 times the amount of money that I'm investing at that interest rate, which is 12,000 minus X dollars. Interest. This is an amount of interest. Those are the amounts of interest that I'm earning on my two investments. If I add those two amounts of interest together, I'll end up with total interest earned, TIE. That is not an industry term that I'm aware of. I just made that up. Total interest earned. You should probably write that out. If only I knew from this problem the total amount of interest that I was going to be earning by making these two investments. Oh wait, $13.35 is the total amount of interest that I'm going to earn. What you have here now is one equation with one variable in it. All you have to do is a little bit of distribution, which requires multiplication. You'll combine like terms, and you'll solve for your variable. Let's keep going with it. 0.105x plus, now I need 0.12 times 12,000. The 12 times 12 makes 144 with 3 zeros after it. Slide the decimal to the left a couple of places. We'll only have 1 0 after it. That makes 144 with a 0. Or you can do it in your calculator. See, this math I can do. Simple subtraction though, forget it. Minus 0.12x. So I've distributed, and you should put a little note up here, DIST. Okay, that's still equal to the 1335. And now on the left-hand side, I'm going to combine like terms. So I've got 0.105 minus 0.12. So that's 0.105 minus 0.12, and that's equal to negative 0.015. We still have that positive 1440 on the left-hand side of the equation. That's equal to 1335 still on the right-hand side of the equation. And I'm going to start isolating my variable. I forgot my variable. Just sneak it in there after the 0.015, put a little x in there. And now I'm going to isolate the variable. It's already negative on the left-hand side of the equation. I don't love that, but it is what it is. It'll be okay. Leave it there. Subtract 1440 from both sides. 1335 minus 1440 is equal to negative 105. And then we have to divide both sides of our equation. That's a division symbol. Divide both sides by negative 0.015. I've already got the negative 105 in my calculator, so I'm just hitting divided by. Oh, except there's all sorts of weird things in my calculator now. All right, I'm starting that one over. I've got 105, which I'm making negative, and I'm going to divide it by negative 0.015, and I get a final answer of 7,000. So x equals $7,000. It's been so long. At which interest rate is it that I'm investing the $7,000? Because if it's a multiple choice scenario on an exam or a quiz maybe, you don't want to assign that $7,000 to the wrong investment. Thankfully, right up here under me, we put a little note that says we were investing X dollars at 10.5%. So that's the $7,000. We could put a note down here at 10.5%. Total invested was $12,000, so 12,000 minus 7,000. I'm going back up here again. 12,000 minus 7,000 is $5,000, and that's how much you're going to invest at 12%. All right, there it is. There is a dual investment problem. You've never had so much fun. The next problem is a mixture problem, and it's very similar to your dual investment problem. You have a cleaning agent. I'm not going to work this one out. I want to do the next problem after this one, which is a distance rate times time kind of a problem. But let's just talk about this real quick, because you might run into one of these. You've got a cleaning agent. As a cleaning agent, a solution that is 40% vinegar is needed. Okay? So instead of using Windex, you can make vinegar water and wash your windows with vinegar water. It doesn't smell very good, but it's not toxic, which is good. And then if you want to use something where you're not going to get any lint, supposedly you can use newspaper, because newspaper is made of cotton or something, I think. So there's no lint involved. Anyway, how much pure vinegar should be added to a 25% vinegar solution in order to obtain 50 ounces of a 40% solution? So what's happening here is that we're adding pure vinegar, which is stronger than the 40% vinegar solution that we need. So we're adding pure, which is too strong, to a 25% vinegar solution, which is too weak, and we have to add the correct amount of each in order to end up with a specific amount, 50 ounces, at 40% solution. This problem is so similar to the previous problem that we did. You're going to add X ounces of 100% concentration. That's the pure stuff. You're going to add 50 minus X ounces of 25% solution. You'll turn these two statements into little multiplication problems. .25 times the 50 minus X. And now, instead of these being two interest values, these are two amounts of vinegar. 100% of that really strong stuff that you were pouring into your solution, 100% of that was vinegar. And only 25% of the other amount was pure vinegar. So this is also an amount of vinegar. And that's equal to your final amount of vinegar. Now, yes, the problem tells us that we have 50 ounces of a 40% solution, what does that mean? Means you've got a 50-ounce container, whatever that looks like. It's a jar or it's a spray bottle or something. And inside those 50 ounces in your spray bottle, is that pure vinegar? No. Some of it's probably water. Only 40% of it is pure vinegar. Where am I? Oops, sorry, I'm off screen. I just wrote this. 40% of, because there's multiplication in there, your 50 ounces of cleaning solution is, what's it made of? Vinegar. So I've taken this solution problem, and yet again, it's really nice. I've got the x variable here, and instead of putting a y right here, I wrote it as 50 minus x, because I know what y is. I started out with 50 ounces. Some of those x ounces were pure vinegar, and some of those total 50 ounces were only 25% solution. So here again, you've got one equation with one variable. You need to do some distributing, some multiplication, combining like terms, isolate your variable. All of the same steps that we did in the previous problem. So very important that you're seeing the similarity between these two types of problems. And finally, oh, that's interesting. So I'm at the end of my PDF, so I can't scroll up any farther, so I've got to actually drag my screen up here. That works. Okay. So we've got distance, rate, and time in this problem. John jogged for 8 miles per hour for the first part of a race, then increased to 12 miles per hour for the second part of the race. If the race course was 21 miles long and John finished it in 2 hours, how far did he jog at the faster pace? So distance is equal to rate times time. We're being given a rate. So we know that rate times time is equal to distance. Well, that's already written at the top of the page for us. At 8 miles per hour, which is a rate, I'm still going to write it, RT. So 8 miles per hour, you can put units in there, times, now for how long was he running at 8 miles per hour? I don't know. So I'm going to call it T. And you can write additional notes in here if you need to. Time, amount of time spent running at 8 miles per hour. Okay? R times T is equal to a distance. Then there's this other distance that he ran. So that's a plus sign. He ran that at 12 miles per hour. Times some other amount of time. Maybe he spent the same amount of time running at these two different rates. I don't know. But let's pretend it's a different amount of time. Well, how much time did he spend running total? The answer to that question is 2 hours. So out of those 2 hours, if he already spent T amount of time running at 8 miles per hour, he's got the rest of those 2 hours left over that he spends running at 12 miles per hour. Now this is a distance, and this is a distance. Wouldn't it be nice? D1, D2, D total. Wouldn't it be nice if the problem told us the total amount of distance that John jogged? If the race course was 21 miles long, right, the problem says that. So don't hesitate to keep looking back into the problem and making sure that you're using all of the data given to you. Typically, especially at the earlier stages of a chapter or in what's maybe considered an easier word problem, you're going to need to use all of the information given to you. So here, that total distance was 21 miles. And look what we've created yet again. One equation, one variable, distribute, combine like terms, isolate the variable. You got your answer. Or at least you think you have your answer. When you finally solve this equation, you're going to have a t value. That t value represents the amount of time, and maybe you even wrote this down when I said, don't forget, it's okay if you want to put additional notes in here. Lowercase t represents the amount of time that John spent running at 8 miles per hour. Let's read the question one more time. How far did he jog at the faster pace? We don't want the t value. We want this value over here, 2 minus t. That's the amount of time spent running at the faster pace of 12 miles per hour. Some of these things that I was circling and underlining were only really good while I was talking about them. I don't want those there anymore. All right, that is the end of some applied problems in Chapter 1, Section 2. We did a bunch of substitution here. Really, instead of there being a T2 value in here, I don't know if my cursor is showing up on the screen. It's being recorded or not. It's supposed to be, but I never know if it is. That was an eraser. This value right here, I could have called that T2, and this could have been T1. We would have had two variables. Instead, I already decided a different way to describe T2, and I put it there in place of a T2 and wrote it as 2 minus T. That could be considered substitution. Up here, where we wrote 50 minus X, I could have written the letter Y, but then I would have two variables. And I would have to take note of the fact that X plus Y equals 50 ounces total, and we would have had to do substitution, and you can do it that way. I could have presented it that way, but I'm trying to go through the logic really slowly with you so that you can avoid that step and just make the connection to the fact that, look, you can do it. This plus this, what's X plus 50 minus X? Well, the positive X and the minus X, those are going to cancel out. We're left with 50. Oh yeah, we've got 50 ounces of our final solution. We did the same thing in this problem. We had X dollars invested at this interest rate, and instead of Y dollars invested at the second interest rate, we just did whatever was going to be left over, which was 12,000 minus our first investment. So you're seeing the pattern on those, which is hopefully going to make those problems easier. If I were you, having taken notes on those, I would then go back in and jot down the original word problems. Or if you're working with software that's generating similar problems for you, you could just go into the software and use those problems. But if you wanted to, you could come back in and use these problems, pause the video so that you've got empty space underneath the original problem, write down the details of it, try to recall how to replicate this process. Be thinking about the logic behind what it is that you're writing down. Because if you can establish that logical thought process in your mind, that's what's going to serve you very well if you run into one of these questions on a test. And hopefully, problem-solving skills and those kinds of things are going to serve you well outside of the classroom and outside of a math class also. All right, I'm getting into life lessons, which means I've gone too far. Gotta go. Thanks so much. See you next time. Bye.